Hello everyone, I Suvarna Mujumdar, Assistant Professor in Electronics and Communication Department of Ajay Kumar Garg Engineering College, going to present a lecture on microprocessor KCS 403. This subject is running in second year for CS students. In this syllabus, we are going to cover first unit, that is all about microprocessor, its evolution, its type. We are also going to discuss about the architecture of microprocessor and its components, the different addressing modes, interrupts, what is interrupts, how this helps to work as in a microprocessor, the data transfer scheme in microprocessor. We are also going to discuss about the instruction and data flow, the timers and the timing diagram related to microprocessor, and the devices which we are going to interface with microprocessor, so that we can use microprocessor in the world. Second unit is all about, specifically we are going to discuss about 8085 microprocessor. This is the base of microprocessor, and we are going to discuss about its pin diagram, its architecture, whatever the registers implied in this 8085 microprocessor, its interrupt, machine cycle, and also we are going to discuss about the instruction sets associated with 8085 microprocessor, its addressing modes, the classification of instruction on the basis of types and operation that are going to perform through address instructions. In the third unit, we are going to discuss about 8086 microprocessor, which is the advanced microprocessor. It is a 16-bit microprocessor, and in this microprocessor a new term came into picture, that is all about pipelining, and we are going to discuss about this 8086 microprocessor, its interfacing, its architecture, its instruction set, and also we are going to discuss about the interrupt, that is hardware and software interrupts associated with 8086 microprocessor. In unit number 4, we are going to discuss about the programming part of 8085 as well as 8086 microprocessor. So, how we are going to write an assembly language program for either for 8085 or 8086. So, to understand the programming part, we must have to revise about the different types of instructions associated with this microprocessor, and also we have to discuss about the programming techniques, like how we are going to write about program for delay, stacks, subroutines, and how we are going to use different instructions like call and return. In unit number 5, we are going to discuss about different peripheral device. So, these are some ICs, these are some peripheral device, that is 8237 DMA, 8255 programmable peripheral interface, 8253 that is timer IC, 8259 which is programmable interrupt controller, and lastly we are going to discuss about UART, that is 8251 and RS232C cable. So, this is all about the syllabus that we are going to cover in this subject microprocessor KCS 403. This is the textbooks that we have to refer while studying all these units. So, the first textbook, that is by Gaonkar, Ramesh Gaonkar. Just I will use pointer. So, the textbook by Ramesh Gaonkar, it is all about the microprocessor programming concept for 8085 microprocessor. Yeah, 8085 microprocessor. So, this is the basic books that we are going to cover while completing our unit number 1 and 2, and for unit number 3, that is all about 8086, we are going to either use a DB Hall book, that is a microprocessor interfacing, which will cover about 8086, and the programming part of 8086 as well as programming part of 8085 will be covered in first and third unit, will be very much sufficient for us to cover the whole syllabus. And in the last unit, that is the 5th unit, we are going to discuss about different types of peripheral ICs. So, for that we can refer either Renu Singh book microcomputer system, or we will go with Barry B book, that is Intel microprocessor. So, subsequently in lectures I will refer the books related to that particular unit. So, this is lecture number 1. So, in this I am going to first cover, these are the outlines. So, first of all we are going to discuss about how we can define a microprocessor, the components of microprocessor, the basic terms, the microprocessor based systems, its concepts, and the number system, or I can say the last topic is all about the prerequisite for understanding the working of microprocessor. So, the microprocessor, as the term is micro plus processor. So, why this term why this term is given to this device? Because this device, that is microprocessor, it is used to process the data. And why micro? Because it will perform this operation in within a time, small duration. And this device, what I can say is, came into picture or can be used after the invention of transistor, that is in 1948. So, transistor is first appear, then using this transistors, that is BJT device and NMOS device, we are going to have this microprocessor. So, as I told you, it is the evolution in, or we can say that it is evolved after the evolution of transistor. And the definition is, it is a multi-programmable, clock driven, register based digital integrated circuit. So, as I told you, this microprocessor is a integrated circuit, that is, it is available in a chip. Digital integrated circuit. So, we can say that this device needs data in a digital form, and as I told you, it is a multi-programmable. So, we can program it multiple times. We can use this device to perform n number of tasks. It is also clock driven. It needs clock frequency to perform its operation, and it needs some registers to store the data. So, if we have to classify, or if I have to break the definition, so I have to first understand the programming part of microprocessor. I have to understand about the register which is required to store the data, and also about the clock, how this clock is applicable for this microprocessor. So, as I told you that it needs binary data. So, the data which is inserted is binary in form. So, we will see what this binary data means. Then this microprocessor will process this data according to the instruction whatever we had written in the memory unit, and after performing all the operation on the required data, the results is provided by this microprocessor on the output form. Okay. So, as I think all of you are aware of this term, CPU, central processing unit. So, this is what our microprocessor is. It is a CPU on a single chip that contains millions of transistors. So, after the invention of this transistor, it gives us immense pleasure. So, we have this microprocessor in the market, which we are using nowadays to control each and every element, or we can say each and every device. So, what are the components of this microprocessor? So, first is ALU. This ALU stands for arithmetic and logic unit. It is a digital circuit present in a microprocessor to perform all the operation, that is arithmetic and logical operation on the digital data. So, whatever the data we want to process, we give that data as an input to the microprocessor, and in microprocessor this ALU unit will perform all the operations on this data. Then we need a register array that is to store the data. So, this register array is nothing but a smallest element of your memory, or we can say it is a group of flip-flops used to store the data. Okay. So, this is again a digital circuit. It is also a synchronized, or we can say sequential circuit which we are using to store the data. So, arithmetic logic unit is a digital circuit, register is a digital circuit. So, that is why we are going to say that our microprocessor is a digital integrated circuit. Now, the third part, that is the control unit. To perform the operation, microprocessor need this third part, that is the control unit, which will control the flow of data between the microprocessor, memory and the peripheral ICs. Basic terms that are related to a microprocessor. Okay. So, the first term is the chip. As I told you, this microprocessor is a chip, or we can say it is a small thin piece of silicon with a required circuit, and we can say that transistors are used to perform the operation. Bit, which is a fundamental storage unit of our computer. So, here as I told you, we are using binary data. Microprocessor is using binary data. So, data is in the form of 0 and 1. Bit size, it is a number of bits that can be stored or processed by microprocessor simultaneously, or we can say it is the number of bits which can be processed by ALU unit. Okay. So, the bit size, whenever we are defining that microprocessor is 8-bit microprocessor or 16-bit microprocessor, what it means, what it signifies? It signifies that the number of bits that can be processed by the microprocessor at a particular clock cycle. Okay. So, we in our syllabus we have to discuss or we are to study about the 8-bit microprocessor, we have to discuss about 16-bit microprocessor, and right now if in today's scenario we are having a 32-bit microprocessor or 64-bit. Okay. Right now our system, our computer is of 32-bit processor, or it is a 64-bit processor, means it is processing a 64-bit data at a time. At a time it is processing 64-bit data. Okay. The next term is just I will clear it. Okay. The byte, that is next terminology that we have to remember is byte, that is 8-bit word which is referred as a byte. As I told you, that is 1 byte, we can have 2 byte or we can have 1 kilobyte. And next term is nibble, it is a group of 4-bit data. Okay. So, as you can relate it as 1 byte equals to 2 nibble. Okay, you have to remember these terms because we are using these terms in while writing a program or while understanding the working of our microprocessor. Okay. So, nibble means group of 4 bits, and 2 nibble will constitute a 1 byte, then 1 kilobyte, or have we can define this this kilobyte. Kilo means 10 raised to power 3. Okay, as we know, this is 10 raised to power 3. In case of binary data, that is 0101, kilo means it is approximately equals to 2 raised to power 10. Okay. In normal standard unit, we are using 10 raised to power 3 as a kilo, but in case of digital, we are using 2 raised to power 10 as 1 kilo, that is 1024 byte. So, approximately we are saying that it is 1000. Okay. Next term is megabyte. So, mega means, again mega means you all know about that, it is 10 raised to power 6, but here we are having it as 2 raised to power 20. Okay, because here base is 2, binary base is 2, this is in decimal number system, we will see what this number system is. So, here megabytes means 2 raised to power 20 bytes. Now, the next term is bus. So, bus is nothing but a group of wires which are used to carry the information from microprocessor to other peripheral device. Okay. And system bus, we can have a group of buses and we can make it as a system bus. Just giving a term, and I will cover these terms and then we will have one diagram to understand it properly. Then we have a memory. Memory is a unit which is used to store the data so that microprocessor can refer this data afterwards whenever it requires. Okay, right now I think you all are using different types of memory to store the data, whether it is scan disk or hard disk, or you can say USB pen drive. These all are the secondary storage device, but here we are dealing with the main memory, that is RAM and ROM, that is random access memory, and ROM, that is read only memory. So here microprocessor needs this memory unit to store the data as well as the program. Then the input device, I think all of you are aware of these input device, but just for recall, input device are the device which are used by microprocessor to takes the data, like keyboard, mouse, scanner, all these are the input device because these devices will give input to the microprocessor. Then the next term is output device. So, the whatever the results after manipulation, after any arithmetic or logical operation, whatever the result is available, that result we need to be displayed on the our screen. So, our monitor is one of the output device, our printer is second output device. We can have many more output device, like we have motor, we can have a LED, we can have LCD displays, all these are output device which are used to produce the results or to display the results. Okay. Then the next term that is used is computer architecture. So, as microprocessor is the base of your computer, so it is a heart, or you can say the brain, and it is a computer architecture in which we are going to arrange these devices in a way. So, in case of Von-Neuman architecture, as I told you, this is our microprocessor, it is a chip. We need a memory to communicate. So, microprocessor will takes the data from this memory or gives the data to this memory, and then microprocessor needs an input output devices, IO devices for communication. So, these are our system bus. Or you can say the electrical wires which we use to connect the input output devices with the microprocessor or with the memory. This bus are further classified into three. One is address, one is data, and one is control. Okay. So, I am just giving one example to understand this microprocessor very clearly, that if I have to share some data with any of the other person, I have to first mention the name of that person to whom I am going to share this data. So, that name of that person, you can consider it as an address. Now, the information, whatever the data, whatever the file that I am going to send is my data information. Okay, and how I am going to proceed, at what time I am sharing my information with that person, and other details like through mail or through WhatsApp and for any other media. So, that is all about the control part, that how I am going to share my information with the other person. So, these are the three buses that we have to microprocessor will use to share the information or data either with input output device or with memory. Okay. So, in Von-Neuman architecture, whatever the data and the program that we have to go, we want microprocessor to perform some task. So, we have to give some instruction to microprocessor. So, whatever that program, or we can say the code is, and the data on which the microprocessor has to perform that task, that both are written in the same memory, means we are using this memory for storage of code, that is program, as well as we are using this memory to store the data. Okay. So, in that architecture is known as Von-Neuman architecture, and in case of Harvard architecture we use separate memory, one is code memory, one we use as a data memory to communicate with microprocessor, okay, and then microprocessor is connected to input output devices. Okay. So, in case of Harvard architecture we are using separate memory, one for code storage, one for data storage, and it will help microprocessor to respond fast with faster speeds, because at a time microprocessor can take the data from code, that is it will take the instruction from code and same time it will take the data from data memory. So, it will we will have a parallel processing type information, but mostly we are having a Von-Neuman architecture. So, whatever the microprocessor we are going to cover in our syllabus, it is all about on Von-Neuman architecture, means same memory is used for code and data. And this Harvard architecture is mostly preferred by microcontroller, which is used to specify a specific task. Then the next term is CISC processor and the RISC processor. So, as I told you that microprocessor is a device which process our information. So, how it going to process? So, there are two ways the microprocessor can process our data. One is it will take information or instruction in such a way that it is complex in nature, means at a time one instruction can perform many machine operation, like it can read the data, it can store some data. So, that instruction is doing multiple tasking. So, we can say that that type of processor is complex in nature. Okay. And the second processor is RISC, that is reduced instruction set for computer, in which the instruction is written in such a way that it can perform one machine operation. We will see it in detail also in next our subsequent lectures, but these are the terms that we are going to use while defining any of our processor. Now, this is the microprocessor based system. This CPU is I can say that central processing unit or our microprocessor. It can send, first of all it can send the address on the address bus. So, the address is communicated from microprocessor. Now, with this address microprocessor, this address will reach to each unit, that is it will reach to memory, it will reach to input device also, and it will reach to output device also. Okay, whatever the address we had transmitted. Now, this control bus will be came into picture, and it will decide that particular address which is generated is for memory or input device or for output device. So, now the control bus come into picture, and this control signal is generated by microprocessor, and it will be sent to the memory unit, input output devices and output devices, so that it can for example, first address is all about memory. So, this address is reached to all, but this control signal will be reaching to only to memory. So, next two device will be rejected, because right now microprocessor is communicating with memory only. Okay. Now, the address is reached to memory, the instruction is control signal is reached to memory. Now, memory microprocessor has also performed some give some instruction, like it has to read the data or it has to write the data from memory. So, that control signal is again generated from microprocessor, whether it has to read the data from memory or write into the data into the memory. Suppose microprocessor has to read the data. So, the data will be travelled on this data bus, okay, and the data will be reached to microprocessor. Okay. So, microprocessor has to communicate with input device, output device as well as with memory. Now, these are some basic concepts of microprocessor, or we can say the definitions which we are going to cover is, first is microcomputer. So, a computer with microprocessor as its CPU, it includes memory and IO device that whole system is known as microcomputer. And the chip which consists of only a register array and register array, ALU and control circuit, that chip, silicon chip, is known as microprocessor. And if that silicon chip itself consists of some memory unit and IO device, then that term, that single silicon chip is known as microcontroller. So, the difference is we have a microprocessor. So, this microprocessor you can classify into three terms. Okay. This is microprocessor, that it consists of ALU, register array and control unit. This is all, these three are on a single chip. Okay. When it is communicating with IO devices and memory, then this whole system become your computer. Okay. And if a single chip, it consists of ALU, register array, control unit, memory and IO device on a single chip, then it is known as microcontroller. So, in our syllabus we have to cover only the microprocessor parts, or you can say we have to interface microprocessor with memory as well as input output device to construct a computer. So, we have to discuss only these two terms in detail. This microcontroller is not in our syllabus, but we will discuss it later, how we are going to design any microcontroller. Okay. So, the prerequisite of this syllabus means, before going to discuss about the microprocessor in detail, we just have to recall something from digital part, that is digital circuit, we can say the subject that computer organization. Okay. So, first of all I am going to discuss about the number system. Actually, as I told you that microprocessor is a digital circuit. So, it is a machine, it needs some information, and that information is in the form of a signal, and we can consider it as a digital integrated circuit. So, we can say that the signal will be of either of the two form, that is either it will be having 0 or 1. Okay. So, your machine, that is microprocessor, can understand only a binary information, that is 0 1 0 1 data. But as a human being, we know a number system, that is decimal number system. We always process the data in this decimal number system. Okay. That we remember counting from 0 1 2 3 up to 9, then 10 11 12 13. So, as a user or as a human being, we will have a number system, that is 0 1 9. But machine, that is your microprocessor, it understood only 0 1 0 1, that is digital signal. You can say VCC and ground, 1 is represented by VCC and 0 is represented by ground or 0 volt. Okay. So, microprocessor will understand 0 1 language, that is your binary language, your binary number system. But we know about decimal number system, 0 1 2, and there is one more number system, that is hexadecimal number system. Okay. Why this number system come into picture? Because as a user, we remember only this number system, but machine remember 0 1 0 1, binary number system, you can say binary 0 1. So, we need a system which will be in between, so that a user can also understood that language and machine cannot. So, we will convert our number system, we will use hexadecimal number system, which is an intermediate number system between a user and a machine language. So, we will discuss this in next lecture in detail about the number system, and also I am going to discuss about the digital circuit like combinational circuit as well as sequential circuit like decoder and flip flops, because these are the prerequisites to understand the microprocessor in detail or in clear picture. So, that's all. Thank you.